have to email this to people. Our new standard, changing land, and it's just continuing what we've been talking about, erosion and weathering and landforms and all of that, and it says to analyze and interpret data. That just means we're going to have data and we're going to talk about what it means. To determine the effects of weathering. What's weathering?
What's happening?
Breaking apart. And the rate of erosion. That's what's different about this standard than what we've been talking about. We know erosion is washing things away. The rate of erosion is how fast it happens or how slowly it happens. So that's what we're going to be talking about this week. The rate of erosion by water, ice, wind, and vegetation. What's vegetation? Plants. Good. Okay, so that's our new standard. The first thing we're going to do, a little demonstration. You can either watch me here or you can watch up there, but you need to be able to see the jars and the sugar cubes. Now I'm going to hold the sugar cubes up really close to the camera. They're square. Do you see how the edges are pointy? The corners are pointy, the edges are sharp, okay? The sugar cubes represent land. The gravel and the water represent something that might cause erosion. Now, just based on what we've done the past few weeks, which one of these, gravel or water, do you think is more powerful with erosion?
Gravel.
You think the gravel?
Water.
You think the water. Okay, you said water because I asked it like a question. So let's think about when we have talked about erosion, what are the things that we say carry sediment away? Water. What else? Wind. Ice. Water, wind, ice, or maybe vegetation. What carries the sand away? So some people made both predictions about which one would erode this faster. We're going to start sharp, pointy corners, sharp edges, and we're going to start with the gravel. And I'm going to shake it. We're going to whisper count to 60, and I'm going to shake it for 60 seconds, or a count of 60. Okay, go. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. Okay, now I'm going to take it out. But what just fell out of there? Sugar. But what in science terms?
Sugar.
Sediment. Sediment. And look at the jar. Was all that powder on the jar before? No. So that tells me there's some weathering and some erosion going on. Let's take out the cube. Well, you know it's going to look different because there's part of it on the counter. There's part of it on the counter.
Is that actual sugar?
It is. Look at the edges now. Are they still pointy?
No, they're kind of getting round.
They're kind of getting round. Weathering and erosion are happening with the gravel. Okay, that's your second box on your page. That's your second box on your page. Draw what the cube looked like when it came out of the gravel. So moving gravel took off the edges, took off the corners, and created lots of sediment. Look at the screen now with the sediment in the jar, how much I can wipe away. So,
It's gonna be water because water can dissolve.
And I feel like the water's
Hey.
gonna make it just like
I heard some predictions that the water's gonna
I know it's
dissolve
probably
it.
the
Water,
the fastest because when you shake rocks, it's gonna bust it up. But when you drop it in water and shake it, it'll start dissolving because it'll
Like bath bombs.
yeah.
Like your medicine.
Like medicine, like bath bombs. Like we've talked a lot about rivers rolling and tumbling and breaking things apart. And what about sandstone? If this sugar cube, this new one with pointy sharp edges, if this new one represents a sandstone, what's water going to do to it?
Dissolve it.
Dissolve it. Oh, I like that science word. Okay, so is your prediction that water will be a more powerful agent of erosion than gravel?
Cause like
Okay.
kind of when you make Kool-Aid and it just goes to the.
All right, let's try it. It's just plain water. There goes our sandstone.
Dissolving.
Count to 16. Look, the lid's not on right. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60.
No cube.
There's no cube, but look, really, I'm gonna get really, really close. Can you see some sediment floating around in the water? Yeah, look at the bottom of the jar, just some tiny little pieces floating around.
It's like after
So it was
each,
water.
whenever you put,
Like when you-
put some sand in it and you put some water over it, the sand is kind of like
It just-
it'll just lay there.
Okay.
And like when I made.
So on the first box, you're gonna draw what it looks like when water erodes it, when gravel eroded and water eroded. So which one was the most powerful agent for erosion? Water was. Okay. Don't try to write as quickly as I'm talking, but I want us to think about the questions while you're drawing, and then you'll go back and write your answers. What did you notice about the sugar cubes in both jars? What was similar in both jars? They both got damaged. They both were eroded. They both were eroded, or they both were weathered. What did you notice at the bottom of the jar? Well, we can't. Well, you can kind of see at the bottom. You can kind of see at the bottom, but you can definitely see along the sides. What is that from the rock? Well, the powder is sediment. There was sediment at the bottom of the jar. There's a little bit of sediment at the bottom of the water. A little bit, some tiny little grains. And did the this one's easy. Did the rocks or the water break down the sugar cube more? Water. Which jar produced the most sediments?
The gravel.
The gravel. There's more sediment in the gravel. You can see it. Because it just dissolved in the water. Okay. You can click stop.